Hello everyone, welcome back to the data science exam series. Today we are going to cover question number 5 in this video. Here we have two major classification topics. So basically in part A we will compare parametric and non-parametric models and supervised and unsupervised learning. In part B we will understand accuracy, precision, recall and F1 score using confidence metrics. So let's begin with this question. Here, distinguish between parametric and non-parametric models, supervised and unsupervised learning with examples. So, what are parametric models? Parametric model assume a fixed mathematical form. That means we already assume the shape of the function before seeing the data. These models learn a finite number of parameters. So, what's the example? Linear regression, logistic regression, nearby. And when we are talking about non-parametric models, so these models do not assume a fixed function in advance. They learn flexible patterns directly from the data and parameters and may increase as data increases. So here the example is k nearest neighbor, decision tree, and random forest. So parametric models are simple and faster, but less flexible, as well as non-parametric models are more powerful but need more data. So here on the screen, you will see one tabular form representation of parametric and non-parametric model. Here we have some parameters on which we classify these two different models like meaning, complexity, data requirement, training time, flexibility, interpretability, assumption, and example algorithm. So you can check out from here. After this, we have another concept called supervised and unsupervised learning. So what the supervised learning is like, we train using label data and output is already known. So here example is spam classification, price prediction, sentiment analysis. Goal is prediction. This is the main core concept used for supervised learning. And if we are talking about unsupervised learning, so no label data, the model automatically finds hidden patterns. This is called the unsupervised learning, where example here is clustering, customers, anomaly detection. So basically unsupervised learning works on unlabeled data and finds hidden structure. These are all the parameters written on which supervised and unsupervised are differentiated, distinguished from each other. Also, like customer segmentation, anomaly detection, and market basket analysis. These are all the type of unsupervised learning. So like supervised is predict output and unsupervised is discover patterns. Parametric is fixed form and non-parametric is flexible form. So these four terms are always paired in data science theory questions, so the examiner expects a table plus examples which we already explained clearly. On moving with the part B, define accuracy, precision, recall, F1 and illustrate their computation using confusion metrics. Here, evaluation metrics are used to measure the performance of a classification model. For binary classification, 4 values are obtained from confusion metrics. Like we have 4 values, true positive, true negative, false positive, and false negative. Here, accuracy, correct prediction out of all prediction, is known as accuracy. The formula written on the screen, meaning how many total predictions are correct. Then precision out of predicted positive, how many were correct. This is the main concept of precision. Here the formula written on the screen. Also useful when false positive must be avoided. For example, spam email. Next is recall. Recall out of actual positives, how many were detected is the recall. TP equal TP upon TP plus Fn is the formula. Last one is F1 score. F1 score is a harmonic mean of precision and recall balances both false positive and false negative. Also the formula is written on the screen. So we have discussed this using a small example, like suppose TP equal to 40, Tn 30, Fp 10 and Fn 20. So on applying these values to these formula, we got different values like accuracy 0.7 means 70%, precision 0.8 means 80%, recall 67%, F1 is around 73%. So we see that accuracy alone never tell the full story. That is why we use these extra metrics. So alright everyone, this question number 5, and if you understood, you have covered two major core ideas of machine learning evaluation. In the next video, we will start with question number 6, which is learn linear regression and logistic regression with formulas and practical examples. So don't miss the next part. Like, share and subscribe. See you soon. Thank you.